Hello, so I decided to go with the first problem in the homework assignment for this exam. So let's go to the question. Okay. So for part A, it says if a fourth vector, which is D, is added to vectors A plus B plus C, the result is 0. So A plus B plus C plus D equals 0. And it wants us to find the magnitude of D. So first, let's go over what is given to us in the problem. So it says to choose the positive x-axis as east and the positive y-axis as north. So for what is given to us, vectors A is 72.4 meters and 32 degrees east of north. And then for vector B, we have 57.3 meters and it's 36 degrees south of west. And then lastly, for vector C, we have 17.8 meters due south. So with this information that is given to us, we have to break down vectors A, B, and C into their x and y components. We have to add those components, take that negative, and then that will allow us to get the components of D, and then from there we'll find the magnitude. So just to show, this is the first thing we're going to write down, what is given to us. In the text, they do help us by telling us which trig functions to use. So if the direction given is the angle from the x-axis, then we will use cosine for the x component. And then we'll use sine to find the y component. And then this is vice versa for if we have the angle from the y-axis. So if we have the angle from the y-axis, we're going to use cosine for the y component. And then we'll use sine to find the x component. So this is a good rule of thumb to follow, because if it's cosine, that means that it's adjacent to the angle, and if we use sine, that means that it's opposite to that angle. So I just went ahead and I wrote that down here. So this will help us to easily more follow along with when we're gonna find the components. So moving on, the first thing we want to do is to write down how to actually find these components. So we're gonna start off with the for vector A. So to find the x component for vector A, we're gonna do the 72.4 meters times sine, because it's opposite to the angle, and it's gonna be sine times 32 degrees. And then for the y component of A, we're gonna do 72.4 meters times cosine, because this time it's adjacent to the angle, 32 degrees. So we just write that down like so, right there. And then we're just going to go ahead and enter this into the calculator. So 72.4 times sine 32. We get approximately 38.366. And then to find the y component, we do 72.4 meters times cosine 32 degrees, which leaves us with approximately 61.40. So far we have the x and the y components for A. And now we can move on to the B vector. So we're going to find the x component for B. So it'll be bx equals negative 57.3, because in the given it says 57.3 meters south of west, which means that it's going down, times cosine 36 degrees. And then to find the y component, it's going to be by equals negative, again because it's going south, 0.3 times sine 36 degrees. So if we go ahead and enter that into our calculator, we get approximately, for x, the negative 57.3 times cosine 36. So we get negative 46.356. And then for the y component, negative 57.3 times sine 36, which is about negative 33.680. All right, so now we have our x and y components for A, and then this is our x and y components for B. And then for finding the x and y components of C, we look at the given. So if we look, it only says 17.8 meters due south, which means that this direction does not move either east or west. So the x component for C is 0. So we can just put Cx is 0. And then again, it says 17.8 meters due south, which means that for the y component, Cy, it's negative 17.8. Okay, so now we have our components for A, for B, and then our component x and y components for C. So because if the vector D was added to those three vectors that are given, we get a sum of 0. We can assume that vector D is equal to negative vector A plus vector B plus vector C. So we want to take the negative of each component, each total component, after we find the components for D. So we're going to add up all of our components, and then we're going to take that negative, we're going to make them negative so that we can get the negative component. So to find the totals, we're going to set the total of A, vector A and B and C. We're going to set that to a variable R. So we'll do total for the components, which is going to be R. So that's going to equal to 38.366 plus the x component of B, which is negative. So it'll be 38.366, which is the x component for A, minus 46.356, and then the x component for C, which is 0. And then we're going to go ahead and enter this into the calculator. And then we get approximately -8. I got -7.99. So that means for the total of all the x components, we get -0.799. And now we're going to find the total for all the y components. So the y component for A is 61.40 plus the y component for B, which is -33.680. So it'll be 61.40 minus 33.680, and then the y component for C is -17.8. So then we're going to do minus 17.8, and then we're going to enter this into the calculator. And then we get approximately 9.92. So for our total, which we set to R, the x components is -7.99, and then for y, we get approximately 9.92. So just to show here, this is where we add up the totals for all the x components, add all the totals for the y components, and then we get the total, we get the x and y components for our total of all those vectors, which is these numbers here. So we want vector D so that the total sum is 0, which means that vector D is equal to negative of vector A plus vector B plus vector C. So that therefore equals the negative of vector r. So that means that we have to take the negative of each of the total components. So since the component for the total component value for all the x's was negative 7.99, that number now becomes positive. So it's going to become 7.99, and then the negative value of the y is going to become positive 9.92, which we can write here as just negative 9.92. So now to find the magnitude of vector d, which is how long it is, we need to use the Pythagorean theorem. So now we have our components for vector d, which is dx. The x component for vector d is 7.99, and then the y component for vector d is going to be negative 9.92. And we're going to take this and plug it into the Pythagorean theorem. So let's just write it out here. So vector d, or the magnitude of vector d, is equal to the square root of the x component of vector d squared plus the y component of vector d squared. So we're going to take our x and y components for vector d, plug them into the Pythagorean theorem, and then the solution should give us our magnitude. So it'll be vector d is equal to the square root of 7.99, which is our x component, squared, plus negative 9.92, which is our component for y squared, and then it's going to be square rooted. So 7.99 squared is approximately 63.84, and then we're going to do negative 9.92 squared is approximately negative 9.92. So that's equal to approximately 98.40. And then 63.84 plus 98.40. It's 162.24. And then finally we just square root that. And then equation, we get square root of 162.24 is equal to 12.73. So here we have why we are switching it into, or why we made them negatives, because that's equals sum of 0. And then we take those x and y components for D to then find the magnitude using Pythagorean theorem as used here. And we get a final solution of the magnitude of D is equal to 12.73 meters. And we can add that in there for part A. And then part B of the problem says to state the direction of D in terms of an angle measured counterclockwise from the positive x-axis, and to express our answer in degrees. So to find the reference angle, we need to use the inverse tangent. So that equation is degree equals tan to the power of -1 over the y component for D, and that's the y component of D over the x component of D. So this equation here, this is the inverse tangent, and that allows us to find the reference angle. So with that equation there, we're going to be able to find the reference angle. We have to make sure that we use the absolute values, however, for the x and y components, because calculators, they only go they only give angles from -90 to over 90. So yeah, just make sure to take the absolute value to get the size of that angle. So now we're just gonna go ahead and input that. So we're gonna do the degree D is equal to tangent -1 to power -1 times the absolute value of -9.92 over 7.99. And then if we just go ahead and enter that into our calculator, so we get so yeah, after entering that, we get approximately 51.25. So that's the angle below the x-axis, but since the problem is asking what is the angle measured counterclockwise from the x-axis, we need to subtract it from 360 degrees. Since starting at the x-axis, if we were to go clockwise, we would end up in quadrant 4. So we have to subtract 360 degrees from the initial angle that we got, and then that will give us the positive counterclockwise angle. So for angle D equals 360 degrees minus 51.25 degrees which gives us approximately 308.75 degrees. So to answer the part B, the direction of D in terms of an angle measured counterclockwise from the positive x-axis is 308.75 degrees or 309 degrees, if you want to round up. And then you can see here, this was the inverse tangent, and then we just plugged it in using our x and y components for D. And then after putting it into the calculator, we got our angle measured clockwise. But then to find it counterclockwise, we have to subtract from 360 since it's in the fourth quadrant. And that gives us our final answer of 308 or 309 degrees if you round it. And then for this is fine. Okay, so for part C, it asks us to state in which quadrant angle D from the last part lies. So in the textbook, let's see if I could just draw it out. So 0 degrees essentially points east or to the right. 90 degrees points north or up, and then 180 degrees points west or left, and then 270 degrees points south or down. So if we're starting at the x-axis, if we move counterclockwise 308 degrees, that leaves us in the fourth quadrant. Also, because the x component is negative and then the y component is positive, that means that it's west. So the x component is positive and then the y component is negative. So that means that the it lies in the east and it's going south, which is the fourth quadrant from the x-axis. So that is our answer for part C. In which quadrant does angle D from part B lie? And that is in the fourth quadrant. So now for part D, it says to calculate the magnitude of the vector S equals vector A minus vector B plus C. So what we want to do again here is break down each vector into their components, and then after we have our x and y components, we're going to just plug them in so that way we can end up solving for vector S. So from what we have given for vector A again, so for the x components, it's going to equal 72.4 times sine times 32 degrees. And for the y component, it's 72.4 times cosine 32 degrees. So really, like, the x and y components for A doesn't change in this part, but it's good to just write it down so that way we know what we did to get that value. So the component for vector A, let's just use the same one so we can stay consistent. We put it as I lost the question, so sorry. Okay, so yeah, so for the vector A, we put it as 38.3 3.66, and then for vector y, for the x component, and then for the y component, we put it as 61.40. And then we're gonna do the same again for vector b. So the x component for vector b is going to be, let me see, what did we put here? So it was negative 57.3 cosine 36 degrees. And then for the y component, negative 57.3 times sine 36 degrees. And then again, just to keep the values consistent, because I don't want to round it and get a different outcome, I'm just going to use the same ones from the last problem, but I'll still write down what I did to get that number. So we put down for the x component negative 46.356, and then for y component we got negative 33.680. And then for vector c, again, this one does not change. There is no, the value of the x component is just 0, and then the value of the y component is negative 17.8. So now that we have these values, we want to add up all the components to give us the x and y component for s, which is what the question is asking us to solve for. Let me go back to where it is. So yeah, so it says that s from the question s of x, so we know that vector s equals vector a minus vector b, and then plus vector c. Oh yeah, so let me just show you. Here we found the components for the x and y components for a vector, x and y components for the b vector, and then y components for the c vector. And then this is what the question gives us. It tells us that vector s is equal to vector a minus vector b plus c. So now that we have all our x and y components, we can add them and subtract them respectively for the x component and the y component for s. So to find the x components for s, we just have to plug them in with our x and y components from a, b, and c. So s of x is equal to all the x components for a minus all the x components for b, and then plus all the x components for c. So this is what is given to us from the question. And then to find the components, we're going to use the components that we found for a, b, and c. And then we're going to go ahead and perform the equation, and then that's going to give us our x component for s. So if we go ahead and plug that in, sx is equal to the x component of a, which we put down as 38.366. And then here it says minus the x components for b. So if we look at the x component for b, it's negative 46.356. If we're going to subtract the negative, that means that we have to add it. So this is going to become plus 46.356, and plus the x component for c, which is 0. So we don't have to write anything there, but we will. 0. And then we're gonna go ahead and add this up. So 38.366. That is equal to 84.722. So for our x component for s, it's 84.722. And then we're gonna do the same thing, but this time with the y components. So the y components for s is equal to 61.40. The y component for b is negative 33. And then here we're subtracting that, so we're gonna go ahead and make that positive. So it'd be plus 33.680. And then we're gonna add the y component for c, which is negative 17.8. So if we're gonna add a negative, that means that we're gonna subtract it. So it's gonna be minus 17.8. And then we're gonna go ahead and calculate that. And then we get 77.28 for our y component for s. So I'm just gonna go ahead and show that here. So we just plugged in all of our component values to find the x component for s, and then all our y components to find the y component for s here. And then here is the x component and y component respectively. And then now we want to just calculate the magnitude of s using our x and y components. So magnitude of s, we're going to use the Pythagorean theorem again here. So it's going to be x components of s squared plus the y components of s squared, and that's all going to be square rooted. And now we're just going to plug in our values, which would be the x and y components. So that becomes magnitude of s is equal to the square root of 84.722 squared plus 77.28 squared. And then we're just gonna continue solving that here. 84.722. And that's the square root of 7,177.82 plus 5,972.19. And then continue solving. We're just gonna add these two values together, and we get a square root. The magnitude of s is equal to the square root of 13,150.01. So once we square root that value, we get 114.6. and that is equal to the, 114.6 meters, and that is equal to the magnitude of S. So here we set up the Pythagorean theorem. We plugged in our x and y components for S, and then we continue to solve using our calculator until we get 114.6 meters as our magnitude for S. And then moving on. So for part E, it wants us to state the direction of S in terms of an angle measured counterclockwise from the positive x-axis. So thankfully in the last problem, we just found the x and y components for S. So I'm just gonna quickly go ahead and rewrite them. So for the x component, we put 84.722. And then for the y component, we put 77.28 meters. Okay. So already we can notice that since both the x and y components are positive, that means that most likely it's going to end up in the first quadrant. But we'll get to that after. So now that we have our x and y components for S, we're gonna again use the inverse tangent. So I'm just gonna put the degree of S is equal to tangent to the power of -1 times the y components for S over the x components for X. So this is the inverse tangent equation that we use to find the degree, the direction of which way the vector is going. And then we're just going to plug in our x and y components into this equation. So doing that here, equals 10 to the power of -1. And then our y component is 77.28 over 84.722. And then we're going to use our calculator. And after putting that into our calculator, we get 42.36, or rounded up, it'll be like 0.37 degrees. So here we just plug those in, and then we got our direction. However, the question asks measured counterclockwise from the positive x-axis. So because it's already in the x-axis, because both of the x and y components are positive, that means that it lies in the first quadrant. So part F says state in which quadrant the direction of angle S lies in, and that would be the first quadrant. So that's for part F. Moving on. So it says to find the components of the vector t equals vector A plus vector B plus vector 2C. So we're gonna just go ahead and do that here. So we're gonna find for vector A, we have to find the components, the x and y components for vector A. So for vector A, I just need to go back to our givens so that I can write down the correct values. So 72.4 meters. And the degree. Said 32 degrees east of north, so it'd be times sine 32 degrees, and then for that y component of A, 72.4 meters times cosine 32 degrees. And then for our B, we have 57.3 meters and then 36 degrees south of west. So that would be negative for the x component. Negative, what was it again? Negative 57.3 meters. And then I believe it said south of west. So that means that we are cosine. Yeah, so we use cosine since it's, geez. 36 degrees. And then that angle I believe is 36. Yes, 36 degrees. And then for that y component, it would be negative 57.3 meters times sine 36 degrees. And then for C, the x component is 0, and then the y component, I believe, is negative 17.8 meters. So I just rewrote down the givens there to help out, and then we're gonna solve for their x and y components. So 38.366. $61.40 for the y component of A, negative 46. Okay, so here we just found the x and y components of A. For x, the x component of A is equal to 38.366 meters. The y component for A is equal to 61.40 meters. For the x component of B, it's negative 46.356, and the y component for B is 33.380. And then again for C, the x component was 0. The y component is negative 17.8. Since it says negative, it's due south. Okay. So, sorry about that. So, for the equation, it wants us to find the components of the vector t. So it says 2c. So what we're gonna do is we just have to multiply the values of c, and then you can go ahead and just add up all of those and just plug it into that equation. So for vector t, to find those components, it's going to be the x components of t equal to the x component of a, which we put as 38.366. Let me just first write out what we need to do. So plus a x component plus the bx component plus 2 times the x component for c, and then for the y components we will write the same. Plus 2cy. So this equation is to find the components of t, and then this one's to find the x components of t, and then this is to find the y components of t. So then we just have to plug in our values that we got for our x and y components into this equation and then solve it. So for our x components, the x component of a is 38.366, and then we're gonna add a negative number here because we're adding negative 46.356, which means that we actually have to subtract it. So minus 46.356, and then plus 2 times the number 0, since the x component for c was 0, so it would be just 0 again. And if we go ahead and input that, we get, for the x component of t, it's equal to negative 7.99. And then we're gonna go ahead and do the same thing, plug in our values for y components. So for t of y, the y component for a is 61.40. And then we're gonna subtract 33.380, and then we need to get the value of the y component for c times 2. So the y component for c was negative 17.8. Then if we multiply that by 2, we get negative 35.6. So if we're gonna add negative 35.6 to this equation, we actually have to subtract it since we're subtracting a negative. So it'll be, it'll be negative 35.6. And then once we calculate it, it'll be 61.40 minus 33.380, and then minus 35.6, which is our y component for c times 2. And after adding that, we get approximately negative 7.58. So then our x component for t is equal to negative 7.99 meters. And then our x component for y is equal to negative 7.58 meters. So here you can see that we just took our two equations, one for the x component and then one for the y component, and then we just plugged in our values. And then after calculating everything, we got our total sum of all our x components, which come out to negative 7.99 meters, and then a total for the y components, which is negative 7.58 meters. And now, so now we're gonna move on to part H, which is to find the magnitude of t. So in the last problem, or in the last part, what we did was we just found the x and y components for those two for t. So we just need to use the Pythagorean theorem and then plug in our values so that we can get our magnitude. So for finding the magnitude of t, it's going to be the square root of the x components of t squared plus the y components of y squared. So this is our equation that we need to use to find the magnitude, and we just need to plug in our values that we got from our last part. So let me make sure that I use the same. So to find the absolute value, magnitude of t, we're going to do the square root of the x component of t, which we put as negative 7.99 squared, plus the component for y, the y component of t, which we put as negative 7.58, and then square that. And we need to find the square root of that entire thing. So we're gonna go ahead and first find what those numbers are. So we get the square root of 63.84, and then we get negative 7.58 squared, about 57.46. And I'll continue. Then we need to find the square root of this number. Okay. So here we just plugged in our x and y components into our Pythagorean theorem. After simplifying, 7.94 squared came out to 63.84, then negative 7.58 squared came out to 57.46. Add them together, we get 121.3, and we find the square root of that. So our magnitude of t is equal to about 11.1 meters approximately. And then there we go. Make sure we have our unit. So 11.1 meters. And moving on to part I. For part I, it says to state the direction of t in terms of an angle measured counterclockwise from the positive x-axis. So based off of just looking at our x and y components, the x component for t is negative 7.99, and then the y component for t is negative 7.58. So if we look at the fact that they're both negative, that means that the vector is going down and then to the left. So if it's going down and to the left, that means that it's going to end up in the third quadrant. So first, we just need to use the inverse tangent to allow us to find the reference angle, and then from there we will adjust it for it being in the third quadrant, and then since it's going counterclockwise from the x-axis. So to find the reference angle, the inverse tangent would be degree of t is tangent -1, and then we're gonna need the y components for t over the x components for t. So this will allow us to find our reference angle. So now we just need to plug in our values to be the degree t is equal to tangent -1, and then we put negative 7.58. And then over our x component, which is negative 7.99. Yeah, so here we just substituted the variables here with our values that we got for our x and y components for t. So we're going to continue on and just solve that, and we can use our calculator. So it'd be tangent to the power of -1 times our y component for t, which is negative 7.58, over our x component for t, which is negative 7.99. Enter that, and then we get our reference, our degree equals to 43.5 degrees. So 43.5 degrees is the angle between our vector t and the negative x-axis. But we need to adjust it for it being in the third quadrant. As we mentioned before, both the x and y components are negative. So we need to do a full measurement counterclockwise from the x-axis. Since it's in the third quadrant, what we need to do is we need to add 180 degrees. So that would look like this. Plus the 43.5 get 223.5 degrees. Alright, so here is us adjusting for it being in the third quadrant. So we add 180 degrees since we're measuring counterclockwise from x, and then that gives us 223.5 degrees. So to answer part I, the direction of the vector t in terms of an angle measured counterclockwise from the positive x-axis is about 223.5 degrees. And then part J asks us to state in which quadrant the angle T from the last part lies. And then since the x and y components are both negative, it means the angle goes down and to the left, which leaves us in the third quadrant. And then I can just draw out a quick graph. Sorry, I'm just running out of space. Oops. Okay, so like in the textbook, shows us something similar to like this. This is the first quadrant, and if we're starting in this quadrant and it goes down, moves down, and then to the left, it ends up in our third quadrant. And also because they're both negative, that's why. Okay, and then moving on, where was our next question? Okay, so then our next question, which is for part K. Sorry, I can't read that. It says a hiker undergoes the displacement, which was A in our given. And then the hiker then undergoes a second displacement, so that he ends up 38 meters from her starting point in a direction from her. Okay. A hiker undergoes the displacement A shown in the introduction. The hiker then undergoes a second displacement such that she ends up 38 meters from her starting point in a direction from her starting point that is 37 degrees west of north. And then it tells us to find the magnitude of this second displacement. So for vector A, we know because they traveled 72.4 meters, the magnitude is 72.4. So we can just write that down for vector A. We're still gonna find the x and y components, but we're just gonna treat this like a new question. So for vector A, 72.4 meters, and that says 32 degrees east of north. That was what was in our given. and they end up, so this means that their final displacement, so after moving a certain direction and for a certain distance, they ended up at a magnitude of of 38 meters, and they were going in a direction 37 degrees west of north. So we can make our final displacement, we can just call that vector r, and then we'll call the unknown displacement that led her to end up at vector r, we can just call that vector p. And then the question says that it wants us to find the magnitude of that second displacement. So to find the magnitude of vector p. So essentially vector a plus this unknown vector p equals our total, or our final displacement, which is vector r. So we can use that to help us find p if we just switch it around and put that vector p is equal to that final displacement, which is vector r, minus our initial vector a. So we know what our vector a is, and we know what our vector r is, but we do not know what vector p is, and that's what our question is trying to have us find. We do know, however, that vector a and p equals to vector r, and if we subtract vector r from a, we'll get our vector p. So this is the process that I'm going to use so that I can find the components and then help us find the magnitude of vector p. So first what we have to do is again find our x and y components for vector a. I'm going to write it down here. A so it's going to be for all our x components, 72.4 meters times sine 32, and for our y component, 72.4 times cosine 32 degrees. And then I just want to use same values again. And we put 38.366. And then for our y, okay, 61.40. Now, after we have found out this is just the x and y components of vector a. We have to find the components of our final position, which is that vector from the start to our finish, and we're calling that vector r. So what we have to do, find the components of vector x, or sorry, the x components for vector r. That's going to equal to, what did we say it was? They moved 38 meters west of north. So for our first one, it's going to be negative 38.0 times sine that 37.0, and then r for our y component would be positive 38 times our cosine, and then 37 degrees, 0.0 degrees. Hold on, I may have I'm sorry, 1 second. Okay. Sorry, I thought I had written down the wrong values for it, but I just read the question, so we're okay. Okay, so continuing on, we just took what was given in our given for what that final displacement was, and it said they moved 38 meters and they ended up 37 degrees west of north. So that means that for our x component, we have to put negative 38.0 times sine 37 degrees, and for our y component, put positive 38 times cosine times 37 degrees. And then now we just